Hi guys, welcome to my channel. Let's discuss today about introduction of a transformer, which is a part of an electrical machine, and a few applications of a transformer. Generally, what is meant by transformer? Transformer is nothing but it is a machine. It is as like synchronous machine, induction machine, DC machines. Transformer is also a part of an electrical machine, which converts one voltage level from one circuit to the another circuit by keeping the frequency constant, is known as transformer. Generally, features of a transformer. Transformer is a Transformer is a static device, which means it does not have any moving parts in this machine, which is known as transformer. Due to no moving parts in this transformer, the efficiency of a transformer compared to the remaining all machines in an electrical machine, the transformer has an possesses higher efficiency levels. Another feature of a transformer is, actual definition and the function of a transformer is it converts one level of voltage from one circuit to another level of voltage it converts one level of voltage from one circuit to another level of voltage to another circuit by keeping, as we have previously discussed, it converts one voltage level to another voltage level by keeping frequency as a constant. There will be no change in the frequency. The supply frequency is constantly maintained in this transformer. Another feature, generally, while designing of a transformer is mainly classified as, two types of windings in this machine, which is known as transformer, that are, high voltage HV windings and LV windings. What is HV winding? HV winding is known as the high voltage winding, whereas the LV winding is known as the low voltage winding. The winding, the supply where, the winding which is placed near the higher voltage levels is known as high voltage winding, and the winding which is placed near the low voltage supply is known as lower voltage winding, which is mainly, we call it as a HV and LV windings. But during the working, as coming to the working conditions, while operation of a transformer, these HV and LV windings are again, while in operation, while construction, these are termed as HV and LV, but while in operation, these windings are classified as primary and secondary windings. Primary and secondary windings. The primary is nothing but the winding which are placed at the lower voltage levels is known as primary winding, and the secondary winding is nothing but the winding which are placed at higher voltage sides is known as the secondary winding. Another point here to be noted in transformer, the transformer, as we have discussed earlier, transformer has a greater efficiency compared to the remaining all machines. The efficiency of transformer is around 95 to 99 percentage, which has the greater efficiency comparing remaining all machines. Transformer will be having the greater efficiency. That is because of the reason that it has no moving parts, as a transformer is a static device or static machine. So, in transformer, let's consider a core type transformer. This is a core type transformer. On which this is a transformer core on which we are placing primary winding. This is the primary winding P1, and this is the secondary winding P2. So this is the V1 primary voltage, and coming to this secondary winding, this is the voltage V2. So in this, while in the transformer, we are having the two windings as we have earlier discussed, LV windings and HV windings. These may be LV. If the voltage level is high here, then this would be the HV winding, and the voltage level, if it is high, then the voltage level will be here low, then obviously it will become the LV winding. So based upon the voltage levels, the windings are classified as HV and LV winding. During the operation of a transformer, during the year, the HV and LVs are only considered in the case of a construction of a transformer, while during the operation, these HV and LV windings are called as primary as well as secondary windings. Point to be note here, during only construction only HV and LV will term as an HV and LV windings in electrical machines, but by operation of a machine considered as a primary and secondary windings. Here, note this guys. In this transformer, the two windings are, this is a circuit 1, consider this is circuit 1 and this is a circuit 2. Circuit 1 and this is a circuit 2. It converts one voltage level from one circuit to the another voltage level to the another circuit without change in the frequency. That is, by keeping the frequency constant, it converts one voltage level to the other voltage level. Suppose if here the voltage level is 50 Hz, then it may be here. If it is a step down transformer, then the voltage may be 40 or 30 or below 50 Hz. Sorry guys, 50 volts. It may be 40 volts or 30 volts. If the voltage level here will be suppose 100 volts, then it might be here. If it is a step up transformer, then it might be above 50 in case of 50, and in case of 100 it may be around 200 or something, which is above 100. So here it converts one voltage level from one circuit to another voltage level to another circuit by keeping the frequency constant without electrically connected between two circuits. There is no electrical connection between the two circuits, but these two circuits are magnetically coupled to the between the two circuits. These are magnetically coupled through the flux between them. So these transformer mainly converts energy based on the without electrical connection and the mutual and these two circuits are connected mutually through the flux. This is the main reason and main concept of the phenomenon of the working of a transformer. So we can say that transformer purely works on flux linkages, right? The energy from one voltage level and another voltage is the transformation, and the process runs through the flux. And these flux, the concept of linking of one circuit flux from one circuit to another circuit is comes from the concept of Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. So hence these transformers are runs on the works on the principle of Faraday's laws of electromagnetic induction. Mainly the transformers works on the basic principle of induction. So the main point to be noted here, the transformer mainly works, the working principle of a transformer. What is that working principle of a transformer? We can say it as a Faraday's law of electromagnetic induction. Let's discuss few applications of a transformer. As we have earlier studied, the transformer works on the principle of Faraday's law of electromagnetic induction. So this transformer is used as a coupling device. Transformer is used as a coupling device. It is used in a measuring instruments. As PTs, which are known as potential transfer measuring instruments, are used as PTs and CTs in a measuring instruments. As PT means potential transformer, and CTs are known as the current transformers, which are used for the measuring of the high powers and high currents and high voltages. This is used for measurement of the high voltages, and whereas the current transformers are used for measurement of high level of currents. As measuring instruments are used up to a standard of range, which is have the particular range will be provided for the measurement instruments. For larger than for kV of volts, for thousands of hundreds of currents, these measuring instruments will won't sustain. So that in this case, to measure the high voltage and currents, these PTs and CTs are used. These transformers are used in electronics and power circuits. These are used in electronic and power circuit for impedance matching. It is used in electronic and power circuits for impedance matching. The impedance at source side should be equals to load side. During this condition, the maximum power is delivered from the source to the volt. This is the source and this is the load. During for the maximum transfer of power, should be a condition must be satisfied, that is known as the ZL is equal to ZS is equal to ZL, that the source impedance should be equal to the load impedance. To get a maximum efficiency and maximum power to be delivered, these transformers are used in electronic and power circuits to maximum of energy. And in power systems generally, these transformers are used as step up transformers and step down transformer. Okay, as we have earlier discussed, this is the step up transformer and step down transformer based on the voltage requirement that should be from the generating station to the distribution, that is to the loads, consumers, generating station to the distribution stations. The huge voltage levels are reduced step by step from the generating station, and through the distribution it comes to the load consumer. So during this process, based on the voltage requirement, these voltages are step down and step up as per the requirements. Under such circumstances, these step up and step down voltages are used. And one more last application. Last application of a transformer is transformers are also used as an isolation transformers. Transformers can also used for the purpose of isolation. Hence isolation transformer. The isolation transformers are mainly used in power electronic circuit. These are mainly used in power electronic circuit for to isolate the high power and low power circuits. As you know, there are the two types of circuits, right? Which is one is the higher and lower. To isolate the to isolate, that is to avoid the short circuit or any losses between the two circuits. The isolation is done between higher and lower power circuits. For this process, this transformer the transformer is used in electronic devices or electronic circuits as an isolation transformer. The turns ratio of an isolation transformer is 1:1. Okay. Yeah, this was the concepts and basic terms related to the transformer and the applications of a transformer. Thank you guys for watching the video.